All right, so we're into our next unit, which is related definitely to our last unit because we're dealing with linear equations. And so what we're going to get into today specifically is continuing on solving systems of equations, but this time we're going to do it, well, right now we're going to do it by substitution. Now, again, solving the systems of equations is a nice way of saying find the point of intersection. All right, so I'm going to go through a few examples here of solving by substitution. And so I have two equations here. They're both linear equations. But here's the problem today, is that one equation looks like something we've dealt with before, and the other one does not. Now, some of you may or may not have seen this in grade 9, but an equation that looks in this or is presented in this form is called standard form. All right, so what I have to do when I have something in standard form is I have to use substitution. Now, there's a few different ways to do it, and that's what I'm going to go through. And number one, again, the problem is that this equation number one here, this 2x plus y equals 3, is not like what we're used to. So here's what I'm going to do. I'm going to make it look like something that we're used to. And what that means is, let's get the y by itself. All right, so what I'm going to do is move this 2x over to the other side. And so my equation now becomes y equals, I have a 3 there, and then I bring the 2x, so now it becomes a minus 2x. All right, so now I have equation 1 and equation 2, just like I did before. Now, that's not always going to happen, but that's one of the situations. And so again, at the point of intersection, those y's are the same. In fact, the x's and the y's are the same, but the y are the same. So if these two y's are the same at the point of intersection, then these two guys are the same. So again, it's just like what we did last time, one extra step though. I had to flip this first equation into something that we're used to. But then again, I'm going to, and this is great review, so then I have 3 minus 2x. So that equation is equal to my 6x plus 11. All right, now again, we have an equation where I can solve for x. And so I'm going to move all my x's to one side, numbers to the other. So I'm going to move this 6x over here and this 3 over here. All right, so on the left-hand side of my equation, I have, got to watch my sign here, a minus 2x. The 6x comes over, so it's going to be a minus 6x. My numbers on the right-hand side of my equal sign. I have an 11 there, a positive 11. And this 3 is coming over, so it's going to be minus 3. All right, so again, now just simplifying and solving for x. I have negative 2x and minus 6x. Well, then I'm down 8 x's. All right, then I have an 11 minus 3. Well, that's an 8. And again, the last step is to divide by my numerical coefficient, which is negative 8, the number in front of my variable. And let's see here. So those negative 8s divide each other out. And I get x equals, 8 divided by negative 8 is negative 1. Now that is just, again, the x-coordinate of my point of intersection. I have to now take this negative 1 and substitute it back in. This is not why this is called substitution. It's always our last move into one of the equations. All right, so I'm going to sub x equals negative 1 into, I got to pick one of the equations. And again, they both work. So I just look for the easiest one. I'm going to go with number 2 because we got all positive numbers and it already, y is what we say is isolated. All right, so I'm going to substitute the add x value into the second equation. And so I have y equals 6. My x value was negative 1, so I plug that in, and then I get a plus 11. All right, and let's see here. Figuring out my y value, 6 times negative 1 is negative 6, plus 11. All right, and then finally, putting those two together, I believe I get a positive 5. And again, it's asking me solve the system, state the point of intersection, and so therefore my POI is Well, what do we got here? X value is -1, and my Y value is 5. All right, so again, that one was very similar to what we've done before, except for that we had to switch one of the equations. Now, again, I just told you I was going to show you a few different examples because these can come in a little different shapes and sizes. All right, so we'll try example number 2 here on my note. All right, so we have, again, example 2, two equations. And again, they're not going to look nice like we had before last unit. All right, so I have 3 at first equation. Again, this is called standard form. 3x minus 2y equals 8. And my second equation, which is 4x plus y equals 7. All right, so this is kind of more of a standard substitution question. All right, so again, here's the problem. They are both in standard form. So what I did last example is not going to work. But the first step is going to be the same. And what you look for with substitution is I want to get a variable by itself. And so I look in this first equation, I got a 3x and a -2y. It's hard to get x or y by itself. Not impossible, but just harder. But then I go over to my second equation here, and it says 4x plus y equals 7. Well, I got a y there. So here's what I'm going to do. I'm going to change this equation number 2, just like I did the last example. And I'm going to do it so that I can get my y by itself. And so I'm going to move that 4x over. All right, so now my new equation number 2 is y equals, I have a 7, and I bring the 4x over, so it's a -4x. All right, now again, here's where substitution gets different. Here's where we're actually substituting. Is that I can't do the y equals thing again, where this equation equals this equation. It's not going to work because this is in standard form. This isn't now, but this is. So here's what we're going to do. Because I isolated my y value, y variable, I am going to substitute, and that's where the name comes from. I'm going to sub that equation number 2 into number 1. And here's what happens is I'm going to use my first equation here. I got 3x minus 2y, but I already know what y equals. And so here's where I'm going to make my substitution. Equation number 2 is going to be plugged into number 1. All right, so instead of writing 2 times y, I'm going to write 2 times 7 minus 4x that I had over there. That's where the substitution comes in. And the reason I'm doing that is because I can get one equation with one unknown, right? Now I have an equation with just x's in it, so now I can solve for x and then find my x coordinate of my point of intersection. And then the best part about this stuff, just like before, is the final steps are all the same. All right, so now this equation is a little bit harder because I gotta do a rainbow rule first. We're gonna take this -2 and times it by 7. So that's going to be a -14. I take the -2 and I times it by -4x. So -2 times -4x, that's a positive 8x. And then I have this equals 8 over there. All right. And again, the whole idea here is solving for x. So I'm going to get all my letters, variables on one side, numbers on the other. So this -14, I'm going to move that over. All right. So now I can collect like terms here. I got a 3x and a positive 8x. That's 11 x's. All right. But then on this other side here, I have an 8 and this -14 is moving over. So it's a positive 14. All right, again, I'm just simplifying here. So I got 11x. 8 plus 14 is 22. All right, and then finally, divided by my numerical coefficient, I get an x value that is equal to 2. All right. Like I said, the last move is the same. I have to take this x value and sub it into either equation. I look for the easiest one. And the easiest one, again, this time, isn't number 1. It isn't number 2, but it's actually my new number 2 because I just have y equals. Makes it easier because all I do is sub in the number and I can figure it out. So I'm going to sub x equals 2 into equation number 2, but the new one, the one I have here in blue. All right, so I have y equals 7 minus 4x, but I know x is a 2. There we go. All right, and again, I'm going to figure out the y coordinate of my point of intersection here. So I have 7 minus 4 times 2, which is 8. And, well, 7 minus 8 is negative 1. All right, I've got my x, and I've got my y coordinate. I got my point of intersection. All I have to do is state it. My POI, point of intersection, is, again, the x coordinate always comes first, the left and right number, which is a 2. And the y coordinate, my up and down number, comes next. It is a -1. Is there any questions there? It takes a little bit of practice to get used to these ones, that's for sure. All right, going to do another one, a little bit different. All right. Going to go with example number 5. If you're following along on my note, it's on the website. We do example 5. All right, so example 5. Again, we got 2 equations of a line, right? And of course, they're going to be in standard form, so look a little bit different than we're used to. So my first one here is x plus 4y equals 8. And my second equation here is going to be x minus 3y equals -27. There we go. All right, so again, what you can see is that both of these equations are what's called standard form. And so what I want to do is isolate a variable. Now, I've been isolating y all the time. I always get y by itself. But you look here, I have an x in the first equation all by itself, and not the y. I got a 4y there. Same thing with the second equation. I have I can get the x by itself, but the 3, I got this -3y here. Again, it can be done, but it's a little tougher. I want to do the easiest thing possible. And so what I'm going to do is I'm going to change equation number 2 again. And this time, I'm going to get the x value by itself because it's the easiest. And I can do that by just moving this -3y over to the other side. And so now I get x is equal to, this -3y is moving over to the other side. It's going to be a +3y. And then, of course, I have this -27 there. All right. Now, here again is why this method is called substitution. Because I got the variable by itself, I'm going to take that new equation, equation number 2, and I'm going to sub it back into number 1. So I'm sub equation number 2 into equation number 1. So wherever there's an x in number 1 here, I'm going to put this 3y minus 27 instead. And so this equation is x plus 4y equals 8. But again, just as I said, what I was going to do, there's my equation number 2. Instead of an x, I'm going to put the 3y minus 27. All right. Let's see here. Polynomials, I don't have anything in front of this bracket, so they don't mean anything. I just put them there because I want to show you that I'm substituting for x. So really, this is just 3y minus 27 plus 4y equals 8. Now, in this case, again, the reason I'm substituting is so I can get one equation with one unknown. This time we're going to solve for y first. All right, so I'm going to get all my y's to one side, which is already happening. But I'm going to move this negative 27 over to the other side. So I still got this 3y plus 4y here on the left-hand side of my equal sign. But my numbers here, I got an 8 and a minus 27 moving over, so that's going to be a positive 27. All right, so now it's just simplifying and solving for y. So I have a 7y, and 8 plus 27 is 35. All right, divide by my numerical coefficients, number in front of my variable there, and let's see, 35 divided by 7, I'm getting my y value to be 5. All right, so I'm half done. Probably a little more than that. So now the last step is the same as it has been. I need to take this y value that I know now and substitute it into one of the equations. And it doesn't matter which one, but I think the easiest one here is, again, the new number 2, because the x is already by itself, but it doesn't matter. All right, so I'm going to sub y equals 5 into my new equation number 2. I don't say it's new because it's still the same equation. I just made it look different. All right, where it says x equals 3 times y, which I now know is 5. All right, so x equals 3 times y. Well, y is 5, so plug that in there. All right, and now it's just the math. So 3 times 5 is 15 minus 27. Let's see here. We're going to get a negative number. 15 minus 27, I believe that's negative 12. And there we go. Again, last step. It wants to know what's the point of intersection, the solving the system. And so therefore, my POI is, again, the x comes first. Always goes first, even though I found it second this time. So it's going to be a minus 12 there. And the y value is 5. And there we go. That's substitution. Solving by substitution. Again, it's because our linear equations can be presented in different forms where what we did before doesn't always work. All right. And so at 10:30 today, we're going to look at solving using elimination, which again is another situation where our equations can look a little more complicated. And so we have to use another method to find the point of intersection.